Okay, today we go back into chapter 6 where virtual works. Last time we stopped at example 1. Right. So again, recap what is virtual works. Okay. Now virtual work, the word, the term work. What I mean by the term work? Right. Work. Work is we use capital U to represent work. So when there's an object with a force move in a distance S. So when force combined with the force with the distance traveled, will create work. So U equal to F multiplied by S. So this is just represent the R as the distance traveled by the forces, right? So this one, let's say this object on the left, before start, this is after start. So there will be a motion of from the starting point, from the starting position to the end position. So here you are seeing two motion, where is translation. Translation means move in a straight line. So AB move to a new location, AB, same distance, same direction. We're referring to the vector. So vector, same magnitude. We have the magnitude and direction. So A to A prime, B to B double prime. Okay. And then after that, after the first translation motion, when it reached this B double prime, the object rotate at a certain angle, d theta. Okay, from B prime, rotate to B prime. So here, from B double prime to B prime, we use a section of circle, theta in radian, right? So S and R. So S equal to R theta that you learn in the small section of circle. So the R that you use for your forces, and you know that when a particles move in a circle, the velocity or the force act on a circle will move in a tangent direction, right? This is the force. So when you have a tangent direction, what does it mean? It's always 90 degrees to the center. Okay. So force, this force vector multiplied by the distance traveled will give you work. Okay. So this one we have two work there, translation work and rotation work. Okay. So this one, if a moment, if the work done by the moment, okay, this one by translation, means straight line, go up, go down, straight line. Huh? But what happens if you have rotation by moment? So your work can be write as md theta. Okay, md theta. How you derive the moment? Moment equal to F multiplied by the distance traveled FD, if FR, and the distance of S is R theta. All right, so that's why you get md theta. But anyway, I won't ask you the derivation. I will ask you application of equation. So work, there will be two motion. One is translation, one is rotation. So when there is a translation in straight line, sure you need to use u multiplied by the u equal to force multiplied by the distance traveled must be parallel. Two vector must be parallel, then only can create work. When force vector and distance vector they are 90°, no work, no work. Only when they are reached parallel, then only have work. So when there's a rotation, rotation means moment. When you take moment multiplied by the change of angle, moment will create work also. So this one is translation, this one is rotation. So there are two. Then if the question asks you to apply principle of virtual works, so principle of virtual work means all the work equals 0 or changes of work equals 0. Okay, so we use the delta here means very, very small changes. Very, very small changes, or you can call it virtual changes. This delta is a virtual changes, means very, very small until we cannot measure, but there's some changes. Okay. So for example, what is work? Work is force multiplied by the distance traveled. Must be parallel. Two vector must be parallel, then only can create work. So weight is a force. Force multiplied by the distance traveled, in this case, go down positive. So work and distance traveled is same direction, so you get positive work. If these two vector is opposite direction, let's say force and the distance traveled is not same direction, then your work will be negative. Okay, because it's vector. Because it's vector. Okay. For example, there are two types of work. For example, normal force. Normal force is pointing up, but the delta y is pointing down. So these two vector, the product of these two vector generate negative virtual works. So in equilibrium of total virtual works must be 0. So if the question asks you to use principle of virtual works, means this you need to write delta u equals 0. Then look at the system. Work only when does work exist? Again, there are two kind of scenario where work can exist. When you have a force, when you have a moment. There are two scenario when you have work. So in this case, you only see work. There's no rotation. But if there is a rotation, then you need to add a rotation inside the derivation here. Okay. Okay, so this one we already covered. Okay, so this is another example where if a beam loaded with the external force P and you have a support here. So this is a ball support means there's one force pointing up, AY, point up. This one have a pin. So this B point cannot move left, right, up, down, but it can rotate. So no moment, but they have a BY and BX. Okay, so once you do that, then the question asks you to solve for the virtual works. So this one you can take this one go up. It cannot go down, but it can go up. All right. So the changes of angle is virtual angle delta theta, which is this angle. And as you leave the end of A, the virtual distance can move is delta y. And at the center here, there's a movement of delta y prime also. This represent the distance traveled at the center of the beam through P. Okay, so what do work? By, Bx don't do work because doesn't move. Again, what is work? Work, you need two things, either translation or rotation. So work can only exist when you have force. multiplied by the distance traveled, these two vectors must be go parallel, can be opposite direction, but must be parallel. Moment multiplied by the change of angle, you get positive work. Positive work. So Bx, By do not do work, P do work, Ay do work. Okay, so you put in the equation. How to find delta y? There's a triangular here, right? So delta y, there's a triangular, but this one pin. So when you move this pin, actually these points are moving. If you move fast enough, you will see that point A is moving in a circular motion. And if you turn, it will rotate in a circle. So when it rotates in a circle, you can use this concept that I'll write on the whiteboard. Okay, S equal to R theta. What is S? Is a small section of distance traveled by this small angle here. Okay, so delta y equal to L delta theta. This L delta theta is here, same as this principle I write on the whiteboard here. S equal to R theta. Okay. What about delta y prime? Delta y prime also same, but this one, the length is half L. So this is S, this is R, this is theta. So S equal to R theta. Okay, so your R is half L, your theta is delta theta. Okay, so now you have the distance of your vector distance. Then you put in the virtual work equation. So virtual work, total work, you take A multiply by the distance traveled. Why we can take delta y? Because it moves in a circular motion. Circular motion, all the force is tangent to the curve. So what I mean by tangent, always 90 degree. So this one, tangent, means this AY is go parallel with delta y. It will generate positive work. Work only two things, force and moment. Okay. So AY multiplied by the distance of this one. So delta y equal to L delta theta. P, y negative, because P and delta y, they are different direction. Vector, different vector direction. That's why the work generated is negative. So P and delta y prime, they are different direction. So you generate negative work. Okay. Then since in this diagram, there's no moment. So no need to do the moment work. Then you simplify the equation, pull out the delta theta. And because you are using principle of virtual works equals 0, so you just put in 0. Okay. Now this is a linear equation and the factorize. If the two component equals 0, either one of these must be 0. Right? You know that delta theta, when you move this one, delta theta cannot be 0. So when this one cannot be 0, means this one must be 0. Mathematic terms. So when this one 0, AYL must equal to PL divided by 2. Okay, so you excluding, notice that the term in parentheses actually represent the application of all the moment in B equal 0. Means you take moment. This one actually is the same principle as you take moment at B. You take moment at B. How you calculate moment at B? This one rotate this way. P multiplied by this distance. And this one rotate anti-clockwise. So this one, AY multiplied by the length. Okay. But again, don't mix between moment and principle of virtual works. They look same, but it's a different two concept. One is virtual works, one is moment concept. Don't mix. Okay. Now, previously we stopped at these slides, not slide, these few slides. So what happens if you have all the connected rigid bodies and so on? So you still can use a method for VirtualWorks. If you see the question link like this, then is in the VirtualWorks question. Okay, important point, this one you read. Procedure, how to do analysis, same. You draw free body diagram, solve the external force, and then sketch the diffracted position of the system when the system undergo a positive virtual displacement delta y or delta q or something. All right. Then you solve using the VirtualWorks equation. All right. So there's a lengthy process, but actually only I think three steps. I'll show you in tutorial. So last time we stopped at here. All right. Last time we have difficulty explaining the delta answer. All right. So determine the angle for equilibrium for two-member linkage shown in the figure. Each member has a mass of 10 kilogram. So if you're given a mass and you have two member, so remember to go to the center of the member, have a dot there, then pull down a force W. Write a force of W for each member at the center of the member. Okay. Then after that, you imagine what will happen to the member. If you pull this one, 25 Newton to the right, these two linkage will move up. Right, this one will move up. So DC member will rotate clockwise, anti-clockwise. CB will rotate clockwise. So you draw the free body diagram first. You copy the bodies. Remember to draw the bodies. Take out the connector. Take out the unnecessary component. For example, the roller B. Take out. You only focus on the linkage. Then copy the distance. Copy the distance. Now, for example, D, you take out already. This one is the connector with a pin, so no moment, but you have the dx dy. Okay, dx dy. So we use the common positive sense when we have a pin like this. Dy always point up, dx always pointing to the right. We just assume. All right. So later, if you calculate already, you get negative, means the arrowhead that you put in your free body diagram is wrong. You need to flip the direction. Same with this one. B here, there's an external force 25 Newton. However, don't forget, this object have a contact surface between the roller and the table here. So there's a normal force there. So we put By as a contact force. Okay, you can put Ny or Nby or something. So this one is just focus on B. Okay, so again, correction. Just now I mentioned contact force. Contact force do not related to pinpoint B. Okay, we are focused on the member B. So forget about the normal force just now. Correction. So this one, if you look at the pin B, then pin B, we do the positive sense, means also have By go up, Bx go to the right. Okay, but this one, Bx go to the right because it's free to move to the right, so no Bx. But you have an external force there. Make sense, Okay. Then you put in the distance. So this one is 1. You know this one is 1, this one is 1. And then put in the W for each of the members. W equal to mg. Okay. So if can, don't substitute the value first. You write W equal to mg. Then at the side of the diagram, you can write W equal to mg, substitute W equal to 98.1. Why? Because some of the time, you might press the wrong button in your calculator, then you write the wrong answer. Then it will screw up the rest of the solution. Okay. So once you do that, then you draw the distance from D to B as a XB. Then you draw the angle here. You just copy from the question. After you prepared all the external force, all the known distance, the W, what you do, you need to add in the virtual motion. Virtual motion means if you move B, what will happen to the member? Okay. Okay, just now I mentioned when you pull to the right, the member will go up, right? But you think further, because the mass is 10 kilogram and your pulling force only 25. 25 Newton means if you have a quick calculation, it will be around 2.5 kilogram. You have a 2.5 kilogram here. This one and this one, you got 20 kilogram. So this one is larger than this force. So this member will go down further and not push up. Okay, so just now our earlier hypothesis is wrong because of the forces that we have. So in real case, this object will go down, not go up. Okay, just now I carelessly, I do not consider the 10 kilogram. Okay, so if the question do not say this statement, each member has a mass of 10 kilogram, or the question mentioned, ignore the mass of the linkage, then it will go up. But if the question already give you like what you see on the screen here, each member have the mass of 10 kilogram, then this member will go down because the force of the linkage is larger than the force applied. Okay, then we back to the free body diagram here. Draw the expected motion. Draw the expected motion. Point B will drag to the left. Point B will drag to the left. So when point B drag to the left, you just draw B to a one dot and then complete the triangular. So there is a delta XB that you anticipate that B will move delta XB. And this is the new location of the joint. And this one, member DC will rotate clockwise delta theta. Okay. And the weight, the center mass will move delta Y also. Okay, the mass of two sides also will move delta Y. What else? Okay, then the rest we will do virtual works equation. Virtual works, again, what is work? Work is force, go parallel with the distance traveled. If there is a motion, there's a moment, then moment multiplied by the change of angle, you get work. So there are two input for the work. Okay, so delta is, we assume, given the positive clockwise virtual rotation. So what are the work? What are the forces that do work? Because this D was pinned do not move anywhere, so there's no distance traveled, no work. B does force B will do work because point B was pulled to the left. Okay, so B go this way, force B 25 Newton go to the right, but the distance traveled go to the left. So two vector go opposite. It will still generate work, but it's negative work because of the product of two vector go opposite direction. BY do not go anywhere. BY just sit there, right? Because BY just follow this line, so do not go anywhere. W will do work. There are two W will go do work. W do work, go parallel with the delta y to generate work. So you have two work done by the work here. Okay, on the for member CB and member DC. Okay. So I highlight members that do work. Then put in the virtual work equation, which is you write delta U equals 0. So write all the equation that link with the work, either force or moment. Okay. So we'll complete the equation. So this one you read lah. So we need to find out what is XB in theta terms. So XB, this one equal to, if you cut this one, is XB theta. You know that each one is 1 meter, means that you have a same side triangular. Same side triangular, this one also theta. You have a same side. Then usually you have a 90-degree here. But we're not sure we're not sure. But we can do theta, and we have 1 here. So you have one triangular here with 90-degree here. So this one, let's say I put this one as x prime b. So x prime b equal to 1 cos theta. Okay. Why? Because cos theta equal xb divided by 1. Okay. Wrong. Cos equal to the not cos, is it cos? Yeah, cos side divided by 1. Right. Yeah, correct. Speed divided by 1. So your x prime b is 1 cos theta. So this one you got 2 x prime b. So your xb equal to 2 1 cos theta. Okay, so this one. What about this one? Okay. So wy equal to this one will be same. It's the same concept. This is delta y. Y w is theta. This is 1 meter. And you want to calculate this one. So here and here is sine theta equal to yw divided by 1. So yw equal to 1 sine theta. Because the length is not 1, the length is half. Why? Because you're looking at center of mass. The total length is 1, but here to here is half, right? Here to here is half L, is L. So your W here. So your triangular is half, so here is half. So here is half. Okay. Then you do differentiation. This one, xb equal to 2 cos theta. You write delta xb delta theta. Okay, you do dy dx. Is y equal to something, you do dy dx. So here you have x equal to something, you del x divided by del theta. Okay, you'll get cos, you differentiate, you get minus sine 2, and then you differentiate the theta. This one, you get this one, you get minus 2 sine theta. You move your delta theta to right hand side, you get equation 1. Make sense, huh? Okay, so the rest of this virtual work, your homework, you need to go and see differentiation of trigonometry for theta, cos, sine, all these things. Okay, go home and refresh. You do the same for delta, for wy. You do the same. You write delta y w differentiate by delta theta. You do differentiation of this one. Sine will become cos. Then you move your delta theta to right hand side. Last time you start at here. Okay. So this one I just show you lah. Okay, I put this one in the announcement also in Canvas. I'll also send you the email. So get familiar with this box here, the equation, right? You you differentiate sine x, you get cos. Differentiate cos, you get negative sine. You differentiate tangent, you get sec 2, sec square. Cosine, you get cosine x, cot x, and so on. Okay. In normal case, I will only test you on the left-hand side equation. If the question asks you about this one, I will let you know. Okay. And you won't see this equation in the test. We don't put this equation in the appendix. We assume you already know because you already passed your mathematics. Okay. So we go back to the virtual work equation. Okay. So this one is just to ask you whether you understand the work done by the W and force, whether they are positive or negative. Okay. So we already explained this one. So you write the equation. W multiplied by this distance, you create work. You have 2 work here done by the W plus the distance, the 25 Newton work. Yeah. Okay. So you recall all the X, Y, all the things, all the things that in theta. Okay, all these things. You have all these things. Substitute back here. Solve linear equation. Okay, try to understand the concept, because the alphabet or the angle will change. Okay. So you do, at the end, you arrive at the angle. Yeah. This one, if you arrive, usually this on virtual work, you arrive at cos and sine. What you do, tangent equal